I think that we will continue to see high performance sustainability at the forefront of
Mhm,
innovation. I think it's going to be a slow transition depending on where you are in the
mhm,
world and where
mhm,
you are in the US. And so I think, we're going to see different rates of adoption. I think all of it is going to become faster
mhm,
as we realize the impacts of climate change. And the same holds true with the other element you mentioned, which is resiliency.
mhm,
So as the climate continues to warm, storms are going to be more severe,
mhm.
floods are going to be more severe, droughts will be more
Right,
severe, hurricanes will be
right.
more frequent. And the the approach to build buildings and homes that are more resilient to disaster is going to continue to increase. And I think those two are going to go hand in hand.
Welcome to Home Green Homes podcast. This is Izumi Tanaka. I am a green realtor and a host of this show. I invited Todd Usher of Addison Homes in South Carolina as my guest today. He is the founder and president of this custom home building company. I met him at the Sustainability Summit this past year and saw his presentation, by which I was quite impressed by its succinct and understandable explanation of what makes a home sustainable, high performing, therefore green. Let's go back to the basics. So, Todd, thank you so much for being here with me today. I really appreciate your time.
Thank you, Izumi. It's great to be here and be with you today.
Thank you. So, as I said, I am always fascinated about people who end up in this field of green homes or sustainable building, green building, this sphere, because we didn't grow up having this kind of information available. So, I'm just curious if you could share with us a little bit about what your background and how you ended up in this position.
Sure, sure. Well, out of college, I went to work for a large textile and chemical company
Hmm.
called Milliken.
Yes.
And interestingly enough, Milliken was very innovative and very
Mm-hmm.
driven to embrace the best practices
Mm-hmm.
available in industry. And the owner at the time, the president, it was a privately held company. The president and chairman was extremely passionate about sustainability.
Oh, wow.
So almost every manufacturing facility was planted with trees, natural green space.
Ah.
Our corporate campus was actually designated as an arboretum.
Mm.
And while I was there for 8 years. The company even went to a zero landfill policy with their production waste as a
Mm.
company.
Mhm.
So after 8 years in that environment, best practices were ingrained in my psyche.
Mhm.
Sustainability was ingrained in my psyche. And while there, I went back and did my MBA at night and
Mm.
was very interested in running my own business.
Mhm.
And that started by investing in rental property. And I
Mhm.
had a partner, and he was pretty hands off.
Mhm.
I was hands on
Mhm.
and always was willing and able to go repair anything on a rental property, make an improvement, and really found a passion for
Mm.
construction, doing those little projects. And that just grew. I started investing in properties myself
Mm.
and began to flip some properties. And then as I was going through that, I was seeing problems with homes and
Mm.
failures in homes and began to kind of educate myself on what's the right way to do things, what's the best way to do things when
Mhm.
renovating or building. And ultimately that turned into new construction.
Mm.
And when I began to look around in the industry for best practices, I was led towards a green building certification program out of
Mhm.
Atlanta called
Mhm.
Earthcraft House.
Mhm.
And it made so much sense. I went through a 2 day builder training, and that was my aha moment. It was,
Mm.
this is the right way to build a house. This is embracing building science with proven techniques and methods that can build a home that's more comfortable, more energy efficient, more sustainable, and more durable.
Mm.
And so that became our standard, and that was
Mhm.
2003.
Wow.
So about 20 years ago.
Yeah.
And Earthcraft House, we adopted Earthcraft House in our new construction practices. And since then, have continually been working to constantly improve and to be more efficient in the way
Mhm.
that we build so
Mhm.
that we can deliver homes that meet these above code standards at a more
Mhm.
affordable price.
Right.
So that's kind of how I came in. And it's been, I've often said to people, it would have been much easier just to build houses to code
Right.
and build as many houses as possible. I
Right.
probably would be a wealthier man today if I had taken that approach, but that's just not my makeup. I'm
Hmm.
driven by doing things differently, innovation, and I really wanted to be able to have homes that in my town that when I'm long gone, my children will hear, "Oh, your dad built our house. We're very happy with it. It's still
Yeah.
doing great today," versus what many people think of builders, which is
Right. Right.
never would call me back when I had an
Hmm.
issue. So yeah,
Yeah.
yeah.
So when did you set up Addison Homes?
So Addison Homes started in 2002.
Oh
That's when
wow.
I
So
formed
wow.
formed the company,
Mm-hmm.
and in 2003, that's when I discovered Earthcraft House
Earthcraft. Uh-huh.
and the Energy Star program and
Mm.
built our first house to
I
those
see.
standards.
I see.
And it was kind of a test. I approached the
Yeah,
client
I would
and I said, "Hey, I've learned
imagine.
about this new program. Would you be willing to let me do it on your house?" And
Yeah,
they were willing, and they became our test case. It
that's
was,
amazing.
the performance
Mm-hmm.
proved what
Mm-hmm.
we were told it would.
Mm-hmm.
They had
Mm-hmm.
extremely low utility bills, great
Mm-hmm.
comfort,
Mm-hmm.
and I saw no reason for us to make that an option.
Mm-hmm.
It made more sense to me for that to be our standard.
Yeah, yeah,
And I
yeah.
felt that making that our standard, we could be more efficient
Right.
at,
Exactly. So
yeah,
I am so glad that you started that so early in the game. I'm sure you were one of the very few people doing that back then in,
definitely,
early 2000.
definitely.
Yeah. So tell
And
me,
and
hmm
yeah, go ahead. I
no,
was just going to say, and after all, I am in South Carolina, so we're
hmm
still one of the very few
Oh,
that do
yes.
this.
Yeah.
We're not in a state that has really embraced energy
Hmm.
efficiency or sustainability in
Right,
any
right.
meaningful way.
Yeah. Yeah.
So we're
So
still one
yeah.
of the few.
So let's talk about that. So in your book, and like I said, your presentation, which I asked you to show us today on
Right.
sustainable homes or high performing homes, were so great. I've seen so many explanations and presentations about it, but it just really hit me with a lot of delight. Oh, this is great that you can explain it this way. So let's hear how you define your high performance or energy efficient homes, and if you could
Sure,
yeah, if you could
sure.
share
And
your deck and
let me
go through
share
that.
my screen here,
Hmm.
and I'll just as a reminder, was more talking about the innovations and the specific
Right.
building
Hmm.
practices that we use
Hmm.
to build a more energy efficient and sustainable home,
Hmm.
and that are readily available today.
Right, right.
So let me share my screen here. So in this presentation, really, I focus on several key components of building a sustainable home: the building
Hmm.
envelope, the insulated shell, indoor air quality, which most of us are very aware of these days,
Hmm.
efficient equipment in the home, and smart technology, because we're seeing more and more evolution in smart technology and how it can help us understand how our homes are working.
Hmm.
So with the building envelope, and Zumi, just interrupt me if you have questions or anything.
Of course.
Um, what do we do? I think you probably remember when I said in extreme weather, what do we do? It's winter time, and we put on a jacket.
Right.
And in my presentation, I have this jacket that has slits cut in it. So there are all these slits and gaps
Hmm.
in the jacket. And as most of us could guess, that doesn't work very well. A jacket that you put on and have slits in it
Right.
doesn't work too well. But that's exactly how we typically build a home
Hmm.
in the US. So this picture is an image that most of us could see on a frosty morning or a morning with dew.
Hmm.
If you drive through a neighborhood, you'll see these mysterious lines on the outside of the building. And
Mm.
when we look closer, that's actually the wood framing. And
Oh.
that wood framing is not a good insulator. So it
Mm.
conducts heat through the building envelope. And it's kind of our weak link in the
Mm.
building envelope. We fill the
Right.
cavities with insulation, but we don't do anything with all of the wood. And in a typical new home today, about 25% of that wall is wood, and it's not insulated like the cavity is. So what we do instead, and what many high performance builders who focus on energy efficiency have started doing, is using exterior insulation, essentially a jacket for your house.
Right. Like
So all of
windbreaker.
the, that's right. That's
Mhm.
right. It's a windbreaker and an insulation jacket. And what that does is that improves the energy efficiency of that 25% of our exterior wall that's wood by
Mhm.
wrapping it with this exterior insulation, and improves the insulation value of even the cavities that we do insulate between the studs. So I talk about, this product. This is a fairly popular product now.
Mhm.
It's an exterior sheathing that actually has a water barrier in it, so it helps keep
Mhm.
water out of the house. And this manufacturer makes an insulated version.
Oh
So you can
wow.
see here, it's got a layer of foam insulation laminated to
Oh.
the structural sheathing, and we just apply it to the outside of the house. And it does two things. It keeps the water out,
Mhm.
it seals the air from leaking in and out, and it gives us that exterior insulation jacket that gives us so much benefit.
Mhm.
Um, and so that exterior insulation really gives us this great comfort
Right.
and consistency and temperature inside the home, and reduces how much money we need to spend heating and cooling.
Right. Mhm.
So the other thing I talk about is air sealing.
Yeah.
So one of the other key approaches to energy efficiency and reducing energy consumption is sealing our building as tight as possible. And many folks say, and there are many builders out there that say, well, you don't want to do that because a house needs to breathe.
Right. I've heard that.
Yep. And the more you talk to folks, they'll say,
Mhm.
well, a house needs to breathe.
Yeah.
The downside in that approach, it's true. A
Yeah.
house does need to breathe. We need
Mhm.
fresh air
Mhm.
coming into our house. So our air sealing strategy is we want to seal that envelope just as tight as we possibly can. But then we want to bring fresh air into
Mhm.
the house and and filter it. So
Mhm.
I'm going to jump ahead here and just look at indoor air quality, because
Mhm.
that's the key. We
Right.
want to manage the quality of the air that we're breathing inside our home. And if we allow the house to be leaky on its own, if we let it breathe,
Mhm.
then we can't control the air quality. We're going to have random air leaking in and out of our
Right.
house,
Right.
going to rob the insulation of its insulating value. And we really need to build it tight and then ventilate it
Mhm.
correctly. So
Mhm.
there's a mantra amongst high performance builders: build it tight and ventilate it right.
Right.
And
Oh, that's a good mantra.
yeah, build tight, vent right. And if you look at the statistics, here we spend 90% of our time indoors. This is an
Mhm.
EPA study that was done years ago, and yet our indoor air quality is often 2 to 5 times more polluted than the outdoor air.
Mhm.
And, we have particulates, we have cooking odors, cooking gases, we have um, cleaning products, you name it.
Mhm.
So what we really want to do is make sure that any point sources of contaminants to the indoor air, that we're, number one, exhausting those to the outside.
Right.
So our range hoods over our cooktops, really important to make sure that those range hoods are vented to the outside.
Mm.
Many of them just recirculate air inside the
Yes.
home.
Yes, mine does.
Yeah, yeah,
I need to
and
change that.
that's right. That's right. A lot of folks, when we talk about this, they start going, oh no.
I know.
But those recirculating hoods, they often have a carbon filter, but rarely do we change those. And
Mhm.
absolute best practice is to vent those contaminants,
Yeah.
those off gases from cooking to the outside.
Yeah.
We also want to make sure that we filter the indoor air so
Mm.
that we can remove any of the particulate matter that's inside.
Right.
You wouldn't really think about it, but even when you cook, there are many particulates in addition to the gases
Mhm.
that come off of the cooking process. There are many particulates that come out into the air that we breathe.
Right.
And what the EPA has begun to realize, and the health community as well, is these particulates that are really small. They're called the PM 2.5. So
Right.
down in the lower right,
Mhm.
2.5 microns and smaller. And to give you an idea, like this slide, that's these little red dots. So these little red dots relative to the size, to the
Right.
diameter of the human hair.
Mhm. Mhm.
And those particulates can go directly through our lungs into our
Lungs.
bloodstream. And we just don't have a full understanding. The medical community doesn't fully understand what impact those can have on our health,
Mhm.
but they
Mhm.
know that it's not good.
Right.
So we want to get those particulates out of the building. Even our bath fans, so
Mhm.
our ventilation fans where we're taking showers and baths, that humidity is
Mm-hmm.
another indoor contaminant, potential
Right.
contaminant. We don't want
Mm.
humidity to build up in the building, so we want
Right.
to exhaust those to the outside. And we're often using some newer smart devices like this switch controller here
Mm-hmm.
that control that vent fan and will automatically turn it on if the humidity level rises above a certain
Mm-hmm.
threshold. And then we'll automatically run that fan for up to an hour
Mm-hmm.
to remove all of the excess humidity. So we don't have a buildup of humidity that could lead to mold or mildew
Mm-hmm.
in our
Mm-hmm.
homes. And so with all of this, we've got a tight envelope. We want to seal it up as tight as we can. We want to vent, exhaust out the bad stuff, and we want to bring in fresh air. And
Mm-hmm.
the easiest way to do that is to bring fresh air in through the heating and cooling system
Mm-hmm.
because it can easily be distributed throughout the home.
Mm-hmm.
And we do that with a simple fresh air intake and
Mm-hmm.
typically like to pass that through a filter. So we're
Mm-hmm.
filtering the fresh air from outside and then filter the whole house air. So we're bringing a small amount of fresh air in on a regular basis. We're filtering that fresh air and we're filtering all of the indoor air with a very efficient air filter. So that efficient air filter is gonna even capture those PM 2.5 particulates. Those
Mm-hmm.
super small particulates will be captured by an efficient filter. And normally these filters are going to be 5 inches thick and some will have carbon impregnated in them so that they will actually remove ozone and other contaminants. But these filters are the lungs of our house, right? Our
Mm-hmm. Mm-hmm.
cooling system is crucial for the air that we breathe.
How often
So
do homeowners replace that filter?
it really depends on the home and
Mm-hmm.
how well air sealed it is. So what we
Yes,
find is
obviously.
in our new homes that are very airtight,
Mm-hmm.
that if a homeowner doesn't have pets that have a lot of fur or dander, if they, you know,
Mm-hmm.
don't have a lot of in and out, say they're not, out in the country, they're not tracking mud or dirt in,
Right.
they could change the filter as infrequently as every year.
Oh, wow.
So if they, we've had clients that live on a farm, have a
Mm-hmm.
lot of animals,
Mm-hmm.
track a lot of dirt and dust
Right.
in and out. Those might have to change more often, maybe
Right.
every 2 or 3 months.
I see.
Um, but either way, these filters, these super efficient filters, they cost about $100 a piece. They're
Mm.
not inexpensive. But what we find from homeowners is that they notice far less dust in the house.
Mm-hmm.
We've had clients that suffered from allergies
Mm-hmm.
before they moved
Mm-hmm.
into a new high performance home with this type of filtration, and those symptoms went away
Mm.
after moving into the home. So
Mm-hmm.
it's no surprise with as
Right.
much time as we spend in our homes.
Right. Right.
And then while we're talking about the equipment, the lungs of our house, if you will,
Right.
we want to make sure it's very efficient. And one of the most efficient technologies that we use quite frequently in high performance homes are heat pumps.
Mm-hmm.
So we're moving away from fossil fuels in
Yep.
new homes. We're moving more towards electrification
Mm-hmm.
across the board. And heat pumps are an extremely efficient way to move heat.
Mm-hmm.
And so the heat pump cycle can be air conditioning in the summer and heat in the winter. And it can do it in an extremely efficient fashion, far more efficient than any gas or oil furnace can operate, to the tune of 2 to 3 times more efficient.
Yes. Yes.
And heat pump technology has evolved to where it's now readily available in water heaters.
Mm-hmm.
So we see most of our homes have heat pump water heaters where, we could save an average $500 or $600 a year
Mm-hmm.
with a non-California electric rate. I'll say,
Yes.
in California, it'd be even more,
Yes.
all
Absolutely.
because of the efficiency of a heat pump.
Mm-hmm.
And that is truly, we can be up to 400% efficient with heat pump technology in
Mm.
space heating and cooling and water heating. And then the most recent kind of innovation in heat pump technology is heat pump dryers.
Right.
So I don't have one. I'm anxious to figure out how I can justify purchasing a new one.
Mm-hmm.
But these are clothes dryers that actually use that heat pump cycle to warm the clothes, to dry them out. And it's far more gentle than electric or gas dryers. And it
Right.
doesn't require a duct to the outside.
Mm-hmm.
So you're not exhausting
Mm-hmm.
all of that heat to the outside. So efficient equipment through heat pump technology is another critical element for building
Mm-hmm.
sustainable homes. And then I touch on smart technology because many of these systems can operate far more efficiently using smart thermostats and other smart tech controls. These systems can monitor humidity, they can monitor air quality, and then operate the system to bring fresh air in
Mm-hmm.
or to dehumidify the inside air without the homeowner having to touch them,
Right.
which is really evolved in the comfort
Mm-hmm.
controls for homes. So you can kind of set it and forget it, let it do all the work, and you don't have to constantly make adjustments to the thermostat. Air quality monitoring is another newer smart tech control. Many of the
Mm-hmm.
smart thermostats actually have air quality monitoring built in.
Mm-hmm.
So they'll monitor the outdoor air quality, they'll monitor the indoor air quality, and they'll decide whether it makes sense to ventilate with fresh air,
Mm-hmm.
filter, run the fan to filter the air more, or even dehumidify. And then we've got a number of air quality monitors that indoor air quality geeks like myself love to use and carry around with us in different places, so that we get a better understanding of what the air quality is around us.
Mm-hmm.
Um, and we even have now the ability to monitor the systems in the homes
Mm-hmm.
that we build. So I think one of the key aspects that I see moving forward is home builders, especially of high performance homes, being more involved in helping homeowners understand whether their home is performing as it should or
Right.
whether some corrective action might be needed.
Mm-hmm.
And I think there's a huge opportunity for builders to be proactive in that process.
I agree.
So we know the
Mm-hmm.
house hopefully better than anyone.
Right. Right.
And if we can monitor some of the elements of how the house is operating, then we can proactively alert the homeowner that we may need to come out and check some of the systems.
Mm-hmm.
So that evolution, I think, is something we're just on the cusp of.
Yes, absolutely.
And of course, smart systems that can help us keep a home from flooding while we're on vacation. It can monitor for water leaks,
Mm-hmm.
and that's become, as you well know, in California, such a hot button
Mm-hmm.
nowadays, water
Indeed. Mm-hmm.
scarcity. So these smart devices will help us understand what our water consumption is,
Mm-hmm.
and will alert us if there's something out of the ordinary, such as a small water leak, so that we can take action to prevent
Mm-hmm.
losing water. Or if we have a pipe freeze that burst, it will automatically shut the water off. And then energy monitoring. So we've started installing these very affordable whole home energy monitoring systems so that our homeowners can see
Mm-hmm.
what impact the different devices they operate in their house have on their overall utility consumption. And when I started building over 20 years ago, these weren't even available. If you
Yes, I was going to say you lived through this whole revolution.
That's right. That's right. I mean, if you
Yeah,
could find something like this, it would have been prohibitively expensive.
right.
And now we can add a device like this onto a home for less than $200.
Yeah.
So it's great that the
Mm-hmm.
technology is evolving the way that it has.
Mm-hmm.
So that was my nutshell of some of
Yeah.
the key elements that are now components of sustainable construction. Of course, there are many, many more,
Mm-hmm.
but in a nutshell, those key practices can get a typical code built home up to a whole new level
Yes,
of
I
performance.
understand. Yeah. And so I am so glad that, we touched on this whole smart technology, how it's evolved over the last 20 years that you've been in this business. Um, yeah,
Now
yes,
stop
there you go.
stop sharing
Yeah.
there.
And in your recent post on LinkedIn, you were talking about design as opposed to gadget. And I
Yes,
also want to discuss the technology, how it might affect our health, because I know that on your website you focus a lot on the health, the
absolutely.
and so high performance home is not necessarily synonymous to healthy homes. Or
Not
how do you bridge the gap in the concept of healthy versus sustainable, for instance? I
it's
mean, yeah,
it's very interesting
yeah.
because so many of the approaches that we use
Mm-hmm.
to build a sustainable home or a more energy efficient home
Mm-hmm.
are very similar, if not identical, to the strategies we would use to build a healthier home.
Mm-hmm.
So air sealing,
Right.
just as I mentioned, if we
Mm-hmm.
can build a house tight and
Right.
then manage the air
Right.
that's coming in versus letting it randomly leak in or
Right.
out
Mm-hmm.
from undesirable sources like the
Mm-hmm.
attic or the
Mm-hmm.
crawl space, then we can dramatically improve the air quality. And better
Mm-hmm.
yet, we can control it.
Mm-hmm.
That's the key. If you have an old leaky house
Mm-hmm.
that happens to have leaks from a crawl space that has mold and mildew,
Mm-hmm.
you have a challenge. You
Right.
got to seal that off or
Mm-hmm.
remove all of that from underneath.
Mm-hmm.
So many
Mm-hmm.
of the strategies complement one another,
Sure.
which makes it very easy for me to
Mm-hmm.
explain to a client how they go hand in hand.
Mm-hmm.
So
Mm-hmm.
while some clients may be uninterested in energy efficiency, they may be like, I'm not worried about my power bill. Um, Very few
Yeah.
of us aren't
Mm.
worried about that, but some folks have, a bigger emphasis on air quality or
Mm.
comfort than they
Mm-hmm.
do energy. And
Mm-hmm.
so it makes it pretty easy, I think, as a
Mm-hmm.
builder
Mm-hmm.
to say to anyone, no matter what your hot button, no matter
Mm-hmm.
what your area of particular interest is,
Mm-hmm.
our approach is probably going to touch on it.
Right.
And it's probably going to make a dramatic improvement in
Right.
that area.
Right.
It's interesting when I meet with clients, and I usually ask the question is, do you or any of your family members have allergies?
Mm-hmm.
And 9 times out of 10, someone in the family does.
Right.
And so health right there
Mm-hmm.
becomes a key
Mm-hmm.
component. Who would say,
Mm-hmm.
no, I don't want a home that's healthier? Um,
Right.
there are very few of us, I think, that would make that
Yeah,
choice.
yeah. So that brings me to that whole concept of, your recent post on LinkedIn about,
Right.
it's not all about the gadgets, I
That's
mean,
right.
like we were saying, there's so much technology available right now, and it's becoming more and more affordable to have those smart technology implemented in a home environment. But
That's right.
that's not all about this, right? Like high performing
Exactly.
home.
Exactly.
Yeah.
If you aren't doing I don't want to word this the wrong way, but if you aren't doing the dumb things, the not
Mm-hmm.
smart things, if
Mm-hmm.
you aren't planning for a tight building envelope and you aren't
Mm-hmm.
insulating the home to the right level based on the
Mm-hmm.
climate that you're in,
Mm-hmm.
if you aren't doing all of those things, there's almost no smart gadget that's
Right.
going to fix that.
Right.
And I think it is challenging when, especially builders market smart homes,
Mm-hmm.
because many of us think, oh, well, if it's a smart home, it must be also energy efficient. And I mean, if it's smart, certainly
Yeah.
it's doing all of those other things well,
Yeah.
but that's not necessarily the case.
Right.
So some of those devices certainly make managing and operating a home easier.
Mm-hmm.
But if you don't get the basic building science elements taken
Mm-hmm.
care of, especially
Mm-hmm.
on a new build,
Mm-hmm.
then again, no smart device is going to fix all of that.
Right.
And one interesting point, smart thermostats. So
Mm-hmm.
one of the key things that smart thermostats offered when they first came out is the ability to roll back the set point when you go to work. So you could
Mm-hmm.
program times of day
Right.
for the house to be at certain temperatures.
Mm-hmm.
And when you go to work, you could turn the heat down and then schedule it to come back on before you get home.
Mm-hmm.
Well, in sustainable high performance homes, we really don't get any benefit from changing the temperature like that.
Mm-hmm. Interesting.
So we actually have found that a home can operate more efficiently just
Mm-hmm.
staying at the same set point temperature, even while you're gone to work during the day, because all of the contents in the home stay at the same temperature. We're not having to then ramp up the system to
Mm-hmm.
heat it back up.
Right.
But on older homes, that can be a smart approach
Mm-hmm.
because older homes are typically more leaky.
Right.
And so they lose that heat or they gain that heat depending on the
Mm-hmm.
season
Mm-hmm.
more quickly. And so setting back the thermostat can be a good solution.
Right.
So it's not always that even the solution the gadget offers isn't always appropriate
Mm-hmm.
for the house you're putting it in.
Yeah.
So there's
Yeah.
a lot of variables there.
Yeah, and speaking of variables, in terms of like if it's newly built, like you
Right.
mentioned in your post, the site matters, and
Absolutely.
the orientation of the home matters, and there's also, like, in certain parts of our countries, or world for that matter, there are, places where we need to look to consider the resiliency of the homes,
Correct.
against different natural disasters and things like that, right?
That's right.
So yeah, so how do you integrate all that when you are, designing?
Well, and
new homes?
those are great questions, and it comes back to those concepts, or even very important before we get to any of the building science that I just
Mm-hmm.
covered in that slide deck. Because if we have the opportunity to position the house
Mm-hmm.
on the site, then we want to take into account where we are in the world, where
Mm-hmm.
the sun path is going
Mm-hmm.
to pass,
Mm-hmm.
where we're going to have potential gain of heat from the sun,
Mm-hmm. Mm-hmm.
and in some cases, we may be able to take advantage of that. In
Yeah.
some cases, we want to avoid that.
Right.
So I always look when we approach a new project, if we have the opportunity, I always look at orientation. Where's
Mm-hmm.
the sun? And in the northern hemisphere, we're
Mm-hmm.
looking at the sun path being to the south.
Mm-hmm.
In the winter, the sun's lower in the sky, but it's always in the southern sky. And in the summer, it's higher in the sky.
Yeah.
And so we can strategically design our windows and our roof overhangs so that in the heat of the summer, we're getting
Mm-hmm.
shade on all of our window
Mm-hmm.
openings so we don't get solar heat gain.
Right.
And in the middle of the winter, we could optimize those to get solar heat gain
Heat.
to
Mm-hmm.
offset our
Mm.
heating. And we often talk about, what's old is new again.
Yeah.
These were the essential
It's true.
practices that
Mm-hmm.
that everyone used before
Mm-hmm.
there was heating and cooling.
Right.
We had tall ceilings so that the heat could rise, and high windows so the heat
Mm-hmm.
could vent out of the building. And all of the old structures before heating and cooling always took into account where the
Mm-hmm.
sun was.
Yeah.
And now, it's kind of like a new thing again.
Right.
We've lost touch. We
Mm-hmm.
started overpowering. We're Americans. We say air conditioning. Well, it doesn't matter. We can build a house anywhere and still heat and cool it. It only takes energy.
Right. Right.
And now we're kind of going in the other direction.
It's
So
really interesting, isn't it, that
it
we're kind
is
of learning from the ancient techniques of,
absolutely.
designing our homes. So what do you think where we're going? What is your vision of
Well,
this home building industry and home living industry? What do you think is coming for us?
I think that we will continue to see high performance sustainability at the forefront of
Hmm.
innovation. I think it's going to be a slow transition depending on where you are in the
Hmm.
world and where
Hmm.
you are in the US. For example, in South Carolina, there's no initiative to increase the standards of energy efficiency for new homes or
Wow.
new buildings. Whereas in California, there are mandates to be
Hmm.
net zero
Yep.
with any new buildings and new
Yep.
homes.
Hmm.
And so I think, we're going to see different rates of adoption. I think all of it is going to become faster
Hmm.
as we realize the impacts of climate change. I think there are very few people that deny that these days. And the same holds true with the other element you mentioned, which is resiliency.
Hmm.
So as the climate continues to warm, storms are going to be more severe,
Hmm.
floods are going to be more severe, droughts will be more
Right.
severe, hurricanes will be
Right.
more frequent. And the approach to build buildings and homes that are more resilient to disaster is going to continue to increase. And I think those two are going to go hand in hand.
Yes, absolutely.
Um, we've started building our homes to a resiliency standard against high wind
Mm.
called Fortified.
Hmm.
And we take a few pretty simple approaches with how we install the roofing on the home
Mm.
that minimizes the chance that the roof will be torn off in a high wind event.
Wow.
And the approach isn't to prevent any damage. The approach is to prevent the homeowners from having to leave their home after a
Right.
disaster.
Right.
So if we can build the home to be resilient enough that they can continue to live in their home after a disaster and have minor repairs, we're far better off
Hmm.
as a country, as a society, because we don't have the large insurance claims, we don't have all of that
Hmm.
work, the displacement, the temporary housing. And I think more and more we're going to see resilience be demanded by consumers,
Yeah. Yeah.
especially when given the choice.
Right. Exactly.
So I
It's,
think that's the key is choice.
yeah.
We want
Yeah.
to inform and educate. Hey, there are other choices you can make that are
Hmm.
above and beyond a code built house, and then let consumers make up their mind.
Hmm. And what is your personal dream?
Well, I hope that we continue to build more and more net zero high performance homes. I dream of building my own home one day. I live in a home that was built in the 1970s, and I renovated it about 12 years ago. But the last of my children are about to finish high school, and so I think the time is approaching where I will soon have a net zero home of my own. So
Oh,
that'll be a fun project to undertake.
uh-huh. Yeah, indeed.
Yeah,
Well, thank you
yeah.
so much, Todd, for sharing your wisdom. I'm
Oh, you're
I'm
so
so
welcome, Jimmy.
grateful. So can you
Anytime.
tell us how we people can find you?
Absolutely. So our website is addison-homes.com. And certainly they can follow us on YouTube
Mm-hmm.
by searching Addison Homes, or even on Instagram,
You have a lot of good
searching
contents
Addison
in
Homes.
there.
So, yep, we're trying to help folks understand the ins and outs of the choices in a very user-friendly, layman's terms explanations of building science and the building concepts that can be implemented to build a much better home.
Yes, indeed. Thank you
So,
so
and thank
much,
you for
Todd.
helping get the word
Oh,
out.
yes,
Yeah.
thank you so much. This was Izumi Tanaka with the Home Green Homes podcast. Thank you so much.